Hello, everyone, and welcome to the Space Initiatives in Georgia event by Mars Society Georgia. My name is Nika Chinchaladze, and I am the founder and president of Mars Society Georgia. And we have a very special guest here today. Martynas Fedotovas is a serial entrepreneur, space advocate, and founder of G.R.S.S, Georgian Research Space Station, an analog research station for manned space mission simulation located in Tbilisi, Georgia. The general objective of G.R.S.S is to create a research platform to support scientific technological development in manned space exploration and support studies in fields like extreme medicine, psychology, biotechnology, robotics, engineering, sociology, architecture, and more. And Martynas is also the member of Mars Society Georgia. So hi there, Martynas, and glad to have you here today.
Hey, Nick, always happy to be talking with you and happy to see, some of the people who are interested to exploring this probably brand new topic that people are going to be here. So first of all, I just wanted to explain again for the people, what is an analog station? Because for some of the people probably who are coming across this term, it's probably brand new. They never heard about that before. So analog station is a simulated station for astronaut-like missions to do based research on humans, with humans, for technology, and any sort of a development towards making humans more sustainable in space or Moon and Mars or other planets in the future as well. So Georgian Research Space Station, this is a project we're currently working on. We are into the phase right now where we're developing a design. So we planning into building phase, and everything is kind of happening at the same time. But this is going to be from the paper to reality very soon, where people in Georgia and other international people can apply for those missions. And obviously, we're going to be discussing that today in a presentation and be part of those missions and experience what does it feel like to be an astronaut while being here on Earth. So what analog missions are for, right? So analog missions, as I mentioned before, is just have those future exploration like space travel destinations to prepare for that while being here on the planet, for Moon and Mars and beyond. To have those stations are very beneficial for, again, a couple of reasons. In this case, it's a threefold, because lower cost, that means for experiments. So if you can imagine, again, going into space or an ISS and trying to conduct some sort of experiment, either for humans, robotics, technology, or anything like that, it costs a lot of money, right? So again, we don't have the microgravity environment here on the planet, but we can actually simulate, again, at least some of the psychological, physiological, technology aspects, and do the research in those type of environments. Risk mitigation, again, before going to Moon and Mars, we want to make sure that we're really prepared. We working on a technology, as we probably heard about the companies just like SpaceX, who are being one of the frontiers in space exploration, space agencies, not from NASA to ISRO, ESA, JAXA, and so forth. So companies, people, individuals, they're working towards space technology and making next level space propulsion systems so we can travel beyond Mars, we can do that quicker. Another thing that we don't pay attention to is human behavior, human psychology, how we're going to interact with other humans from different environments, different belief systems, religions, different, just different human beings, how we can interact with them on a different planet, different environment, while being confined in a small time space for a long period of time. So this is what the main research for analog missions are for, just to make sure that we're prepared as people to continue to do the research, to work, to live, and to sustain ourselves long-term while being on Moon and Mars. So again, those are the thing. The third thing is kind of they're doing the research for psychological long-term analysis, again, which is crucial, intercultural competence, psychosocial models, isolation, interface between people and technology. So G.R.S.S is all about, again, helping to mitigate that risk, right? So as we're talking about going towards Moon and Mars and making all that research with humans, for humans, to make sure that we can sustain ourselves while traveling into space. So what makes us different? So again, this is probably for the people who came across a few analog stations or maybe Googled a few of them before this talk today. So there are analog missions out there, just a handful, just a few across the globe. What will make us different comparing to other analog stations that we're aware of? We know exactly what they do. The thing that is currently missing with analog stations is long duration, bigger crew missions. Meaning everything from 7 people up, because by the NASA standards, and they issued that standard because of the previous missions with the Skylab or ISS continuous missions, to have a crew for these missions as a people of 6-7 people. Obviously, this is good for now, but if we think about long-term mission of us as humans and going into Moon and Mars, this is not a solid approach to do, just because of a simple reason, because people are going to be living in a confined environment with the bigger groups. Obviously, from architectural perspective, we're not going to be building separate dome or whatever type of structures from space side and having 6 or 7 people just for that structure. We're going to build probably huge domes or domes that will be connected to the main dome, and those will support people up to 20, 100, and probably more. So that's what we need to work on, a long-term, bigger crew missions to understand how the psychosociology behavior, understand people nature, and how we can actually include technology and how that can help us to sustain and have less risks while having these long-term missions. Gym fitness research facility, we're going to have a facility dedicated just for that. A lot of stations don't provide that. This is going to be an entire separate block of facility split into 2 parts. And there's going to be a lot of research done with medical institutions that we're currently working with. And we're going to be doing a lot of research on psychology, on human behavior, on physiology, just how people can sustain, and again, creating a specific work programs for training, and it's going to be very, very in depth, because obviously the stations right now with analog missions, what they have is they have a space and they have probably a couple mats and nothing else. So human body is not made to adapt. Maybe it will happen over couple hundred or thousands of years for us being on the Moon and Mars. Maybe we're going to create artificial gravity that's potentially can happen to support us to live in a similar gravity that we have here on Earth, because obviously Moon and Mars, they have 1/6 and 1/3 of the gravity. So preparing human body to even travel through space. Obviously, the first people who are going to be either from private company or from NASA or any of the space agencies, they will be psychologically and physically prepared for those missions and probably to live in there and to work in there. But what about making this and taking to the space tourism, or us going and traveling to Mars and staying there? This is not the science fiction anymore. This is a reality, and we're actually getting very close to it. If some of the people who are actually here in the chat probably following some of the news of the SpaceX or just private companies and where things are going. So focusing on physical aspects of human and how to develop that, how people can train while traveling through space, how you can train and what type of exercises, what sort of equipment you should use while being in 1/3 of the gravity. So those are the questions that nobody is actually looking in depth in analog stations right now. So this is where we're going to focus with our station mainly. So another things that we want to talk about, again, decrease the stress imposed by the habitat. So some of the things that are currently missing with other habitats, and again, I'm not trying to talk badly about other people, they're doing a phenomenal job. Some of the stations out there, they've been doing missions for over 100 crewed missions successfully, 200 and so forth. So all the pieces that all these people, individuals working on successfully doing research on all these aspects that I'm talking about right now, this is really valuable. So our organization and our station is just going to be adding additional value to the space environment, space industry, and just people overall. But some of the things that are missing right now is limited hygiene, chronic exposure to vibration and noise just because of the manufacturing and the materials used in those stations. Limited sleep facilities, which of course over long periods of time having those missions means that we have decreased levels of work efficiency, lightning and illumination, lack of privacy and isolation from support systems. So I would just want to talk briefly about the facilities. So some of those facilities are not going to be different to what other analog stations provide. This is kind of that became a standard in analog community. So GIF witness facility, which as I mentioned before in a previous slide, we're going to be taking a lot of attention and doing a lot of in-depth research and innovation on that part. Electronics and mechanical workshop, obviously doing EVAs, and for that, again, there's a great organization right now developing in Georgia, Georgian Rover Challenge. So we're going to be working again, and Nick is being one of the founders of the company. So we're going to be developing, not developing, but working with those companies and through robotics, doing EVAs, observing, testing the ground, the soil, and so. You know, electronics part is going to be using a lot, even with the AI technology, to help us to mitigate the risk of conflicts and anything like that. I mean, it's a huge topic just on its own. Probably can be a different presentation. Sleeping quarters, mission operations room, hygiene module, EVA area, EVA prep area to do EVAs. Biolab facility, aquaponics and hydroponics area, kitchen area, medical bay, airlock, and prep room. So that's part of the EVA. So what's missing in the habitat? So another thing that's currently missing, and our focus is going to be on that. The name is life support systems. And life support systems are going to be needed. So life support systems means that we keep everything in a tight, closed loop. Everything from, let's say, if we take a shower, where does the water go? Can the water be reused? What about the carbon that we exhale? How we can scrub that carbon and make it into oxygen again? So I mean, this is a high level science that we need to do, and we need to work on that. The reason why other habitats are not working on developing sustainable life support systems, just because it's costly. We understand that too, but we understand the importance of having and developing that. So this is going to be another part that we're going to provide for Georgian people or international people to experience that full life support system while being in development on that with the mission as well. So the question is obviously, how realistic can it be? Because as I mentioned before, there's not going to be an experiences like you floating in space with microgravity. You know, it's not going to be like that. But just from a structural point, having everything closed loop, having life support systems, having tight, very tight plan spaces, working spaces, and dorm spaces for people to sleep, to do the science. So it can become very, very realistic. What sort of a material you're going to use? I mean, there's this entire research that we did for that, just to understand how things are going to look like, because this is an entire industry on its own, which is called space architecture, which is still currently developing right now. And you can find many companies who work on the projects, and some of those projects have been awarded by NASA or ESA, and they're currently looking for the same answers as well. How people can live on Moon and Mars and still have this kind of Earth-like feeling like you're at home, right? So just from psychology aspect, you know, making comfortable environment for people to live and work for long periods of time. So again, I love this quote to death. Werner von Braun, you probably heard this man before. He was one of the main people, if we're talking about the Apollo mission going to Moon, so Saturn V rockets, and he was the engineer, program manager, again, for that program. He said, that's his quote, "Human is not made for space, but with the help of biologists and medical doctors, he or a person can be prepared and accommodated." So that's what the analog missions at the core are. This is, again, a station with the help of biologists, doctors, technical people to develop this sustainable approach of us traveling and living sustainably on Moon and Mars. So again, some of the medical risks in space flights, as we're talking about doing research for medical aspect, again, unpredictable accidents. That happens again on the planet, and it will for sure happen in this very harsh environment which space and Moon and Mars is. How we can deal with trauma and damage, psychological stress, consciousness loss, or death. How those situations, again, before that occurs, how those situations can be mitigated from that aspect, so we can have less unpredictable trauma accidents. And again, how the medical operations will be treated in the microgravity environment. I mean, those are very hard questions for us to answer, because obviously space agencies and private companies are still working on that. So, I mean, we still have no answer how that is going to be done. Obviously, there's technology that's kind of sort of being developed, but still, we're going to be doing a lot of research towards that, how to mitigate unpredictable accidents. Isolation and sensory deprivation, which, as I mentioned before, just because if you have a vibration, noise, there's a lack of room, or the rooms are not being created to support long-term missions, you know, on analog station, on Moon and Mars. You can have sleep disorders, desynchronosis, and things like that. Microgravity, again, as I mentioned before, 1/6 on 1/3, and that can equal to kidney stones, osteoporosis, and lowering of mechanical properties, muscle atrophy, and lowering of contraction force. Artificial environment, again, just a few things: bacteria and fungi infections, that's a big one. How do we treat those? Because obviously, because of the microgravity environment, even medicine that we use here on the ground, just because we have a environment that we have, the medicine doesn't work exactly the same. So there's entire medical industry, which is called space medicine, is working also on that to find an appropriate solution to treat any of the infections, and how do you treat disease, radiation, and more. It goes beyond that. Space radiation, which is obviously very big topic. And again, how do we treat that? Because currently right now with the ISS, we cannot treat astronauts while they are being in space, just obviously because the equipment is too big. It's not possible to transport. There's no space, right? So people have to go back, and that's why astronauts have anything through, you know, 6, 7, 2, a couple month missions. The longest mission was over a year. So they still have to be brought back to Earth and treated for irradiation here on the ground. So what type of technology we can find through that analog mission approach, through traveling people into space, having commercial industry going into space, maybe for a long period of time, and finding those solutions to treat radiation, which is obviously one of the biggest problems with the space flight. So space medicine today and tomorrow. So I kind of talked about that before the slide, that, you know, we are currently dependable of astronauts coming back to Earth, and, you know, how we can do that, you know, solve problems of injuries and operations. So there's a company called Virtual Incision, which, if you Google that, you know, after this presentation, you can find this like fist-sized robots that can perform abdominal operations, abdominal surgery on astronauts. And this is a technology that's been done before prior, and I'm sure there's other technology that's similar to that, and we can try to, you know, either help to handle operations in microgravity or work toward that. But this is, I mean, this is a very big subject, an entire talk on its own. So our mission, again, is to support scientific research. It's not a hotel that we're going to be providing, that people can come in and you know, spend some time. And, you know, I'm an analog astronaut. I've been here for a couple of weeks, and, you know, do the selfies, obviously necessary. But the main goal for the station is doing scientific research, because we and myself and our organization want to add value to the science. And with the help of scientists and medical people, people who work in psychology, is working on finding the solutions that necessary, again, for physiology, psychology solutions, finding those. Robotics is another thing. So again, working anything from supporting EVA, bionic prosthetics, unmanned aerial vehicles, anything to drones, soft robotics that's being explored right now. Biology, geology, doing that sort of a research. Everything that I'm talking right now, this is going to be done inside the habitat. So anything from astrobiology, obviously producing edible crops, keeping us sustained. So again, having that closed loop life support system. Anything to medicine, investigating risk factors of increased CO2 and fluid shifts. That's a big one. Telemedicine, bioengineering techniques, everything beyond that. Exploring 3D printing is also in robotics, in medicine and technology as well. Technology, spacesuit research and development, that's a really big topic. Obviously, as we see right now, things are moving slow with the Artemis mission, just because us going back to the moon, just because they are developing right now a next generation spacesuit. So that means for us traveling into Mars, there will be even next generation spacesuit or going beyond that. So doing research on that, obviously we cannot have a microgravity environment to support that, but to the degree as having as realistical as possible facilities, which we're going to have to support that sort of a research. And as I mentioned before, life support systems. So again, science communication, this is a very big topic. And again, especially here in Georgia, and that's why the topic is, you know, what's happening here in Georgia, right? Things that are happening in space industry in Georgia. So I believe, and as much as Nick believes and other people that are involved in either science or being part of the communities of the Mars Society or anything else, or they into science themselves, they probably believe that science communication is really needed, that still people are out there, they don't know enough about what's happening, like initiatives just like that, which obviously they will find out at some point through the media outlets, you know, TV or radio or something like that, once it's going to go live. But until then, people have just no clue. And obviously, Nick is working on some great stuff, just like Georgian Rover Challenge, which is going to be a next thing for the people to apply the practical engineering things and to apply them in a real case scenario and competing with other people as well. So this is what's needed, and that's what we do. This is what this event today is for, to continue to do the science communication and explain people that it's not only us who are doing stuff. This is part of you. This is why we need you. This is why we need people. This is why we need people to be volunteers, to create companies, to get involved, to work in the science fields. I mean, all these people are necessary for us to explore on this, all this you know, incredible thought that we have to have us as people on Moon and Mars full time. So the question is, again, who can participate for the ones who will be interested after some time to explore a little bit more once we're going to have a station developed, and just to see who is eligible to be part of those analog missions. Obviously, we want to develop those safeguards, as it says, just to make sure that we have the right people, because our approach is different. We want to have long-term missions, which could be really hard for some people. Obviously, we now, because of the COVID, we have some experience with living in a confined environment and being on a lockdown for some time. I mean, it's going to be a similar environment, but worse. Means there's less space, there's other people that you don't know. So how do you handle that situation and still successfully do the research that's necessary to be done? So criteria are anybody, again, men and women aged from 20 to 55, European Union and obviously Georgia. So willingness to be confined and isolated for extended periods of time. So anything from a month going beyond that, because we're going to have even missions going to 6 months and probably beyond that. Again, able to communicate in English and write, you know, quite good, because obviously we're going to have international people. So if you're Georgian, expect to have other international people, probably from US or Europe as well. So just communicating with them and having that team going towards, you know, those tasks that have to be done. Body height, anything from 165, again, 1.65 m or 1.90 m. That's kind of the limit. And the limit for that is basically because we're working on spacesuit development, and those spacesuits are going to be able to carry, again, those people will be able to use those spacesuits if they're that height. So those spacesuits will be developed for that height people. That's the main reason. Technical skills, we're looking for anything from science, engineering, or medical academic degree, or commercial or military pilots. So we're taking, again, things to the extremes. We want professional people to come in just because we're going to have a professional environment to support that. So we're looking for a very tight, you know, group of people. Again, as excellent physical and psychological condition. Again, that's just necessary because of a long-term duration missions. You know, miscommunication happens, you know, just because, right? Because we don't know who we work with. We don't know these people. Obviously, you're going to be trained as analog astronauts before you're going to meet the crew. There's going to be training. There's going to be testing. There's going to be tests that have to be done before you're going to even come into analog station. So you're going to get to meet the crew before that, way before that. But still, psychology and physiology is very important aspects while being in the station. Again, great communication skills, kind of mentioned that. Additional selection criteria might be required because of the different missions that we're going to have with different focus for those specific missions, including confinement, psychology, medical, any sort of a research that we covered before. So again, before closing, space, the final frontier, right? Which, I mean, what else is there, right? We as people, we understand, I understand that we're facing a lot of problems here on the planet that we need to work on. I haven't included, probably I should. I had the separate slides just for medical people that we worked on, for the institutions that we working with towards research on psychology. But I show them just the amount of innovation that came through the space science. If you imagine anything like CAT scans, that's been achieved because of the space travel. And CAT scan or X-ray that we use today every day, and we take it for granted. And even some of those medical people, they were like, I never knew about that before. So it's very normal that everyday people just don't know that X-ray happened just because of the Apollo program, because there was tracking the moon surface for a place to land, and that's why X-ray was developed, just to map the area of the moon. So, and that's how things get developed. So space is the final frontier, and we need to focus on space and creating more initiatives, and we as people getting more involved. And because as you see here through the timeline, since April 12th, 1961, where the first human flew into space safely, there are been many things accomplished just like that until November 20, 1998 with the International Space Station. And now, as you see, after 98, we have many great stuff happening. And right now with the 2021, we see SpaceX, International Space Station, just a level of interest from companies who haven't been part, or individuals who haven't been part of the space before. So everybody is moving towards space to some degree, because believe me when I say that, the people that either you work for, if you're an employee, or in that case, your company will be involved with the space company, or will become part of the space company, or something like that in a near future. So this is inevitable. We're going towards that direction, because for us, obviously, because we're facing a lot of global warming issues and things like that, we need to focus on, as bad as it sounds, just creating plan B, plan C, and things like that. And, obviously, while taking care of and mitigating the risk of CO2 emissions and things like that. So the question is, what's next? So I do encourage more people to participate in all the initiatives that are out there in Georgia, become a member of Mars Society Georgia, and explore what those initiatives are. We obviously are going to be looking for people who can be volunteers with some of those missions. We're going to need people from ground support station. So anything from tracking, analyzing, compiling data. So we have all the information for you. So we're going to be doing the training preparation. You're going to come in an office space, and you're going to be able to track and see what astronauts are working for. So we're going to have a real life experience that you can later apply on, build on, and do something with that in your life in the space industry. So again, if you're looking forward to, get more information, become a partner, because we're still looking for those, or have any questions, want to participate in missions, or want, again, for me to come in and speak about this initiative, explain maybe more about space medicine or technology or anything else, I would be happy to do that as well. So again, this is just my contact details for that.
Great. So thanks for a great presentation, Martynas. And I would like to remind the attendants that there will be a Q&A time now, and they are encouraged to submit their questions in the Zoom chats. All right. So, and before they submit their questions, I have one question just for you, Martynas. So again, you are not a guy with a science background. And now you are here in Georgia and leading the space initiative, as you just described, and that's just one of the things that you're working on. And there are a lot of great things coming as well in the space sector. So how did you find yourself in the space industry?
That's a very good question, obviously. And I think it kind of happened by default, to one degree. But the other thing, I was looking, I was always passionate about space since I was a kid. I remember I used to take a lot of notes from encyclopedias they used to get in school, take a lot of notes, take pictures out of the newspapers and put them in my notebook and track the next, meteor showers and things like that. So my passion was always there. I wanted to do something in space, again, just because at the time when I was younger, there was not much initiatives, again, in my country happening. So it's a simple reason, and that's what I'm saying, because people have to understand right now, because these initiatives are happening right now. You're not in a situation like I was, that you couldn't experience it or be part of something because there was not much, right? So now people have a different situation. So that's kind of how it happened, because, you know, just personal passion and willingness to just explore, because I think naturally we as people were just explorers, coming back to the times of the Columbus, right? So we naturally need to go and explore. I mean, and on the ground, there's a limit. Obviously, we still haven't reached it. There's many oceans that we haven't explored yet, or many, you know, grounds that we haven't explored. But what's more fascinating than space? Well, at least to me. So that's kind of how it led to this place right now.
Great, sounds great. And another question from me would be, like, there are many things happening in Georgia now. Of course, the space industry in Georgia is still like pretty young, but it's growing rapidly. And I promised you all attendance that they're gonna see a lot of things coming pretty soon and hear about that from our events as well. And why do you think that it is important for countries like Georgia to be involved in space sector?
Look, it's going to sound very ridiculous, but why not? Why not? Because, you know, we just had a meeting prior to this, and then I had this connection issue. But the question that we had is like, look, all these other countries that you can think of, pick any country, probably that country is doing something. Either university students, either companies, they maybe have a private, you know, maybe they have a government organization, a space agency. So there's happening. Pick any country, or maybe you can name in a chat right now and another country that has nothing happening, because maybe we can think about some of the countries in Africa. Believe me, as a guy who spends a lot of time in the space industry and has a lot of conversations, there's a lot of great stuff happening in Africa right now, and other countries that we took for granted, kind of third world countries. So look, I believe Georgia is really advanced country. They have great people, great environment to support space ecosystem. Again, space medicine is beyond of, you know, what can be done. So I see a lot of potential there. I mean, there's a lot of great people that can work as a space engineering. But again, coming back to the fact, there's nobody who offering these opportunities for people. So again, we just want to offer these opportunities for people. And again, happy to help with anything that we can possibly can to make that happen here in Georgia.
Sounds great. So there is one question in the chat. From Georgi, and he's asking, is there a plan for Georgia to build a rocket launch pad?
Obviously, yes. It's a shame because I don't know how many of you guys and girls were looking at if you've seen the last Fast and Furious movie, because I showed actually this clip for Nick not long ago, and this is just some real talk that I want to give you to the people, because that kind of give me goosebumps. Even now it gives me goosebumps, just because in that movie, as you know, Fast and Furious been filmed in Tbilisi. There's all these, you know, great stuff. So what it showed as the first scene, it showed like coming to Tbilisi, and the first thing that they show, it's a launching,
taking off, yeah.
Rocket taking off, yeah, from Tbilisi. So my question was, how did the movie producers came about with that thought of picking Tbilisi? Because they've been in like South America filming in different parts. So why Tbilisi in that case? So for me, this is just another way of universe showing that, look, this is a destiny. This is a destined to be, because the question is obviously just like, why not us, as I mentioned before? And there are people who are capable of doing that. The thing is, they don't know yet because they have no practical experience, obviously, and they're missing the know-how. And we're working towards of giving that know-how and giving people life experience to participate in creating those launch pads.
Sounds great. All right, so I guess this completes our session. And again, thanks, Martynas, for your great presentation and the answers. And also thanks everyone for joining and your interest in Mars Society Georgia and our events. And we hope to see you on the next event. Stay tuned for the updates on our social media, and see you all soon.